Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed hydration of alkenes follows Markovnikov's rule, and carbocation intermediates can undergo rearrangements, hydride or methyl shifts, to form more stable carbocations. Moving on to the next step. Draw 3-phenylbut-1-Na. The structure is CH2 is equal to CH-CH, pH, CH3, where the double bond is between C1 and C2 and C3 bears a phenyl group and a methyl group. Moving on to the next step. Protonation of the double bond according to Markovnikov's rule. The proton adds to C1, the terminal carbon, placing the positive charge on C2 CH3 CH plus C2 CH pH CH3. This gives a secondary carbocation at C2. And for the final step, evaluate possibility of rearrangement. The carbocation at C2 is secondary. Adjacent C3 bears a phenyl group. A1, 2-hydride shift from C3 to C2 would move the positive charge to C3, generating a carbocation at C3 that is stabilized by the adjacent phenyl group, benzylic carbocation. A benzylic secondary carbocation is more stable than a simple secondary carbocation due to resonance delocalization into the aromatic ring. The rearranged carbocation is at C3, benzylic position CH3, CH2, C+, pH, CH3. This is a tertiary benzylic carbocation. C3 is attached to CH3, CH to CH3, and pH, making it especially stable. Water attacks the carbocation at C3 followed by deprotonation, giving the alcohol at C3 of the original chain. Let me re-examine. After the 1,2-hydride shift from C3 to C2, the carbocation is now at C3. Structure becomes CH3, CH2. C2 now has H from shift, C+, C3, pH, CH3. C3 is bonded to pH, CH3, and C2, which is now CH to CH3 after receiving the hydride. So C3 carbocation, PHC+, CH3, CH to CH3. This is a tertiary benzylic carbocation. Nucleophilic attack of water on C3 gives PHC of CH3, CH to CH3, which is 2-phenylbutane 2-ol. Why other options fail? A. 3-phenylbutane 1-ol would require anti-Markovnikov addition, not favored. B. 3-phenylbutane 2-ol would be the product without rearrangement. Water attacks C2 secondary carbocation, but this is less stable than the rearranged product. D. 2-phenylbutane 1-ol does not correspond to any logical carbocation intermediate. The rearranged product 2-phenylbutane 2-ol is the major product due to formation of the more stable tertiary benzylic carbocation. Therefore, the correct answer is C. Therefore, the correct answer is option C.